Another example of finding the absolute extrema. This problem, the f of x is 1 over 3 x to the third minus 9x on the interval 0, 4. The closed interval AB, A is 0, B is 4. Step number 1, we find the critical value. Find f prime. F prime is x to the second minus 9. This is a polynomial function which is defined everywhere, so we do not have to consider the case that f prime of x undefined. Critical value would be from solving for x for the f prime of x equals 0. Factor x squared minus 9 to be x minus 3, x plus 3 equals 0. We get two numbers, x equals 3 and x equals negative 3. For the closed interval 0, 4, we keep x equals 3, but we do not keep x equals negative 3 because it's not in the interval 0, 4. Step 2, evaluate the function value at two endpoints and the critical value. So f at 0, f at 4, and f at 3. F at 0, we get 0. F at 4, we have 1 over 3 times 4 to the third minus 9 times 4. 4 to the third is 64. 64 over 3 minus 36, and simplify the number to be negative 14.67. F at 3 is 1 over 3 times 3 to the power 3 minus 9 times 3. And that will give you 9 minus 27 or negative 18. And step 3, compare all the numbers. The largest value, which is the value 0. The value 0 or f at 0 equals 0 is an absolute maximum value. And the lowest or the smallest number is negative 18, occurs at 3. So f at 3, which is negative 18, is an absolute minimum value. As you see the graph, within the interval 0, 4, 0, 4, so the graph is just this small piece. The critical value occurs at x equals 3, which gives you the horizontal tangent. The function value at 0 is 0. The function value at 3, which is negative 18, so we have the absolute maximum at 0, absolute minimum at 3. Application problem. To maximize the profit, a company finds that its profit in dollars for producing X units of a product in 1 week is given by P of X equals negative 2 times X squared plus 1600 times X. If the company is set up so that no more than 500 units can be manufactured in any 1 week, how many units should the company produce to maximize profit? The profit function is provided by Px equals negative 2x squared plus 1600x with the condition that no more than 500 units can be manufactured. The function Px is the polynomial function, and the x or the units with restriction, it has to be between 0 and 500 units. It can be produced within 1 week. To find the number of the units or to find the x that maximize the profit. The other way we say find x that gives you the absolute maximum value of the profit. Step 1, we find the critical value. First, the derivative of the p, which is negative 4x plus 1600. Let it be 0, because we do not have to consider the case that the derivative is undefined. We have x equals negative 1600 divided by negative 4 which is 400. And 400 is between 0 and 500. So we keep this as a critical value to move on to the second step. Second step, we compute the function value, which is the profit at the two endpoints. And at the critical value, at 0, the profit is 0. At 500, or the end of the production line, we have -2 times 500 squared and plus 1600 multiplied by 500. And the number comes out to be 300,000. For P at 400, -2 times 400 squared plus 1600 multiplied by 400 equals 320,000. As you see, the absolute maximum occurs at x equals 400.